Welcome to a screencast for graphing piecewise functions. In this screencast, you will learn how to graph a piecewise function. In order to be successful in this lesson, you should have a pretty good idea about how to graph a linear function. And then after you master this lesson, you should be ready to graph step and other piecewise functions. So we are going to graph a piecewise function with two pieces. So our first piece is 2x minus 1 when x is less than 1, and we have -5 when x is greater than or equal to 1. So I just tend to take a look at each piece at a time. So as we look, I'm just going to focus on this 2x minus 1. And we need to remember that that is for the value x is less than 1. So as we look, when is x less than 1? X is less than 1 here. So remember, we've got like that open circle concept, and we're looking at all of the values to the left of 1. But we're not just focused here on the number line, we are focused everywhere. So on this portion of my graph, that's the function, that's where I'm going to be looking for the function 2x minus 1. So let's graph 2x minus 1. Well, that's in slope-intercept form. So my y-intercept is at -1. And then it's got a slope of 2, so it'd be 2 over 1. So we've got the next point. I'm just going to plot a couple more. And then I can draw my line. Now, one way to do this graphing by piecewise functions is that I only care about 2x minus 1 here in this blue portion. So even though I know my line could go throughout the entire coordinate plane that I see, I'm really just going to focus here on this left-hand side. So when I draw my graph, I'm just going to focus here. Now that I have like a good portion of my line graphed, I need to go back though and think about this x is less than 1. This graph is only true, or that we only use this part of the graph, as x approaches 1 from the left-hand side. But this value here, 1 is not a part of our solution set here. So that solid dot is not appropriate. That dot should really be an open circle. So I'm going to keep that open circle here because it's approaching 1, but it's never actually going to land on 1. So this is what the first piece looks like of my graph. Now let's take a look at the other piece. The other piece of my graph is for when x is greater than or equal to 1. So greater than or equal to 1, that would be that closed circle over here. But again, we need to realize that it's not just this x part of it. What we're talking about is the entire coordinate plane. So for this portion of my graph, I will be looking at that -5. So when we're going to graph -5, that's really just a horizontal line with a y-intercept at -5. So let's talk about the other way that we could graph a piecewise function. So I just know what the horizontal line looks like. It's going to be a horizontal line through this point here, -5. So I need to get my line. And I'm just going to draw the whole line. But we realize, of course, that back here, that's the first part of my piece. I don't need this graph on the left here. My graph really should be starting at this -1. So I'm going to erase that first part and really just focus here on my -5. Now, as I take a look back, x is greater than or equal to 1. A solid circle is appropriate here because when we are looking at the solution for 1, we would be looking at an answer here. So it's appropriate for that to be a solid circle, and we would be moving forward. So this is what our final piecewise function would look like. You just have to kind of figure out which piece belongs where, and then graph and erase, or just graph up to what you need in that zone. So that is how you can graph a piecewise function.